So this exercise assignment is related to group 2 and group 7. The first 50 questions are recorded already. So we'll start with 51 onwards. And about till 44 are like MCQs, multiple choice questions are there. This is important topic. Unit 3, the practical alternative to practical, you will find questions as well related to this topic. So starting with question 51. Okay. So this is a question related to redox group 2 and group 7. Chlorine disinfectant are essential solutions containing chlorine molecules and a chlorate 1 ion in an equilibrium summarized by the equation. So the equation is given. The chlorine content of disinfectant was determined by using the following procedure. A 10 cm cube disinfectant was transferred into a 250 volumetric flask. So first what we did, like we have this volumetric flask is there. The volumetric flask, the capacity of a volumetric flask is 250 cm cube. But only 10 cm cube is transferred. So when 10 cm cube is transferred, it will occupy a small volume. Then what we do, we add water. The deionized water or distilled water is added and until it reaches the mark of 250. What is the purpose of doing this? The purpose of doing this is to make us dilute solution so that when we are doing a titration, we don't have to refill the burette. That's why we dilute the solution. So first we took 10 cm cube of a disinfectant and we fill up to the, like we transfer to 250 cm cube volumetric flask. That disinfectant is 10 cm cube. Then we extra volume, how we complete it? We add like 240 cm cube of a water, so it becomes 250 cm cube, and the solution will change to dilute as it turn into dilute. So when we are using it for titration, it will be much more easy. Like we don't have to refill the burette, otherwise it will increase the error in the experiment. Then after making this solution to 250 cm cube, we just take 20 cm, approximately 20 cm cube of a nitric acid and 20 cm cube of potassium iodide. Both were added to volumetric flask. So because the reaction, so we add nitric acid, we add potassium iodide. Both of them are added to this volumetric flask. Plus the water, we want to make the total volume 250. The solution in the volumetric flask was made up to a mark with the distilled water and then mixed thoroughly. So we mix all the things like 10 cm cube of a disinfectant, 20 cm cube of nitric acid and 20 cm cube of potassium iodide. We add all of them and fill up to 250 cm cube. Then only 10 cm cube portion of the solution in a volumetric flask was titrated. So out of this 250, what we did, we took only 10 cm cube for titration purpose. Like we make a solution dilute, and after making a dilute solution, we took out only 10 cm cube of that sample. And the burette was filled with a, so we have a burette, the burette is filled with a sodium thiosulfate solution. So we have the sodium thiosulfate Na2S2O3. And what we do, we add this sodium thiosulfate because as I mentioned, if a solution contain iodine, as we add potassium iodide, it will form iodine molecule in the solution. When it will form iodine, what will the original color of a solution? It will be brown, or initially it will be brown in color because of the presence of iodine. Then when we add thiosulfate, the concentration will decrease. It will turn yellow. The moment it turned yellow, then we add a starch. Starch is used as an indicator in iodine and thiosulfate. So when we add a starch, the yellow color will change to blue, black. And then again we continue the titration, so it will turn colorless. This is what happened. So sodium thiosulfate with a concentration of 0.1. So we have the concentration. The starch solution was added near the end point, and the average volume, like mean titer, was 27.35. So we have the concentration and we have the volume. So first, how to do this question? Using a concentration into volume, we get moles of thiosulfate. After getting moles of thiosulfate, we'll use a mole ratio to get how many moles of iodine were there. And from moles of iodine, we'll find moles of chlorine in the solution because the ratio is 1:1. So same moles of chlorine. And then this is 10 cm cube. How much original volume will have? Like, because we took out from 250 cm cube, we only took out 10 cm cube. So in the original volume, it will be like 25 times, because 25 multiplied by 10, it will be 250. So the original volume, it will be 25 times the moles what we took here or what we titrated here, because we only took 10 cm cube. So in the original solution of a 250, the mixture of a 250, the moles will be 25 times. So the first part, calculate the number of the moles of thiosulfate. So you have the concentration and you have the volume. So moles is concentration time volume, 0.109, and the volume is cm cube. You have to convert into dm cube, divide by 1000, so 0.02735. So when you multiply, this will give you the moles, which is 0.00298. These are the moles of thiosulfate. Now, how to get the moles of iodine? Use a ratio. What is the ratio between iodine and thiosulfate? According to equation 1:2. So if we have 0.002698, sorry, 298, how many moles will be there? X, cross multiply. So X will be 0.00298 divided by 2. This will give us the moles of iodine, which is half of 0.00149 moles will be there for iodine. Then to get the moles of chlorine, hence the number of moles of chlorine in 10 cm cube solution in the volumetric. So how to work out 10 number of the moles? You got the iodine, from iodine you get the moles of chlorine, but when you check the equation, the mole ratio is 1:1. So if we have 0.00149, this will be X, we'll get the same moles. These are the moles in 10 cm cube, but what is the moles in the original solution? So in the original solution, it will be 25 times. Why 25 times? Because these are the moles in 10 cm cube. We work out like the part which we titrated. But in the original content, calculate the concentration in dm cube in the original disinfectant. So after getting the moles of a chlorine in 10 cm cube, which were 0.00149, it was there in 10 cm cube solution. But what we need originally, the solution was, we made the solution to 250 cm cube mark, because from that 250 cm cube we took out 10. So how many moles will be there? X. We just cross multiply. It will be 25 times, because like 10 into 25 makes 250. So the total moles will be 25 times of this value. So this will be 25 times 0.00149. These are the total moles. And we need the concentration. Concentration is moles over volume. So the moles are 25 times 0.00149, and the volume of a solution, because the total volume of the solution was 250. In the volumetric flask, it was 250. as we took, you can also, the original volume of the disinfectant was 10, and then because what we did, first we were having 10 cm cube of disinfectant, we dilute the solution and make it 250 cm cube, and then we took out 10. So what we did, we got the moles in 10. From moles in 10, we need the moles in 250, so we multiply by 10. But we need the original concentration. So original volume was 10. So this will be 10 or 0.01, the solution. So this will give us the concentration of the chlorine, which is 3.73 moles per dm cube. Then equation 1 is an example of the reaction in which the same element oxidize or reduce using a relevant oxidation number. So why the first reaction, how the same element is oxidized, like chlorine is there, it is 0, and it will form chlorate ion. What is the oxidation number of a chlorate ion here? Because the charge is -1 on this ion. Oxygen is -2, so chlorine should be +1. So in this compound, the chlorine is +1, and a chloride ion, it is -1. So 0 become +1, it's oxidation, and 0 become -1, it is reduction. So same element is being oxidized and reduced. So you will mention here, like in a chlorine. So first we have to define the reaction, proportionation reaction. And so chlorine molecule turned into chlorate ion. The oxidation number changes from 0 to +1. So this changes oxidation. And another one, a chlorine molecule turned into chloride ion. So the oxidation number changes from 0 to -1. So this is reduction. And then the 1 mark is for writing the definition. Then color just before adding the starch, when the solution is very light, what is the appearance? Like when a small quantity of iodine is there, it will be yellow. When starch is added, blue-black. And at the end point, it will be colorless, does not have a color, as the iodine molecules are being completely removed. So this was a question from assignment group 2 and group 7.